All right, so today we're going to be talking about web cache vulnerabilities. So let's just go ahead and start with it. This is going to be a short video just because we don't have any labs and we're going to be taking kind of a high level approach of reviewing things. First, we'll kind of talk about what a web cache is, or moreover, what the problem of a web cache solves. So imagine you've got a website and you are, replying to the same kind of request over and over again. So like if you're a website that tracks the price of some object or something, most of your requests are going to be pretty similar in their nature, and it would make the most sense then to reply to those requests with a cached response. So in this little diagram I've drawn up here, you can see that the web cache sits between the users and the server. So if a user has an original request, the server will make an adequate response, and then the web cache will store it, and then use that response to reply to subsequent requests that it deems to be similar. So that way you solve the problem of unnecessary computations or unnecessary operations being performed by the web server, and reducing the overall strain of the architecture, which is good. The issue is how does this cache determine whether or not a response should be added to the cache, and whether or not that should be used to fulfill similar requests. And it does this using something called a cache key. So those cache keys will contain some set of requests, or some set of like request components, like a host header, or maybe some additional data in the request body. And if this cache key matches that of the previous request, it'll then return a copy of the last response to do so, it'll return a copy of the last response, and then do so until that cached response is considered expired. So because of that, there is a capability of poisoning it, in the sense that if we can determine what cache key is being used, and we can manipulate some kind of attribute of the response, we could try and control if our response is cached, and then utilize that data that we're able to change in the response to perform some kind of malicious action when another user views that cached response. So in order to do that, we need to first identify what the web cache is using to determine if something needs to be cached. So these are called keyed inputs, or cache keys, depending on what terminology you use. So in order to do anything, you're going to need to identify what those keyed inputs are. This could be messing around with the query string. This could be swapping in and out headers. There's a really useful Burp Suite extension called Param Miner. And there's also some command line tools as well that you could use, and some word lists that are pretty straightforward. And automating this process will typically give you some kind of, it'll make your life a lot easier, especially when you're just looking for, some kind of parameter that might be vulnerable. And then once you've at least figured that out, you can tell when you're updating the cache, then you can start looking for any kind of data in the response that you can manipulate. So if you can, like in this screenshot example, you can see that, this JavaScript is going to cause an alert pop-up, but this could be something like leaking the document cookie to, an attacker's domain, and then they would be able to use that to maybe log in as another user or something like that. So, that's where the impact of this gets kind of fuzzy, is that the impact isn't so straightforward. There's a lot of different things you could do with this attack, similar to cross-site scripting and DOM-based attacks. Typically you'll see people trying to execute either cross-site scripting or similar attacks using web cache poisoning. But once you're able to verify what the cache key is, and then you can get some kind of malicious data working in your response, then you just need to try and get that response cached, and then serve it to users in whatever way you need to. If that means sending a link to them where the link isn't harmful, or just using if you're able to poison a response for a really popular web page, that would be part of your impact statement. But that might be the malicious action you're trying to do, is maybe having, a malicious link pop up or something like that. So it really depends, but those are the high level steps of exploiting a web cache poisoning vulnerability. And in this case, in the screenshot, it's just delivering a cross-site scripting payload. Now, this, because of the kind of broad nature that I initially explained this, It leaves out a lot of really intricate details that I quite frankly just wouldn't really have the time to cover in detail respectfully. And you can read a lot into them, and there's labs for a lot of these individual topics on Portswigger's website, which of course will be linked in the description as it always is. But some of these design flaws will allow you to manipulate either like import like JavaScript code imports or cross-site scripting. It really just depends on what you're able to manipulate on the response. And then sometimes you'll actually find out what the parameters are that you can manipulate by either using multiple headers or by viewing verbose responses to determine which headers might be vulnerable, or not so much that the headers are vulnerable, but which headers you can use to actually poison the web cache. And then as far as implementation flaws go, a lot of these have to do with like input sanitization and how the web cache communicates with the web server and its underlying applications. So something like parameter cloaking has to do with the difference in how the web cache might parse an input and how the web application or some other application might parse the parameters that are being included in the query string or the URL. You also might be able to use similar things like that to access internal caches and poison those, or manipulate other parts of the request. So what I would really do is just try to dive into the material for this. There's a lot of good stuff on Portswigger. I wasn't able to find very many good examples of this on like Hack the Box or other CTF platforms that would have been entertaining enough to cover, but that's part of why this video is so short. And then as far as prevention goes, for some of them, it's going to be, one-to-one, but if you're going to be excluding, something from the cache key, so like one of the parameters you're picking or something like that, is just try to rewrite that request instead so that you don't have to use web caching, because ideally, you don't have to use web caching, but, that's only in a perfect world where you have the capability to process every single request, right? If you have a high volume website, you're not at liberty to decide how many users you have and how much strain will be put on your infrastructure, so you need to optimize. Try to make sure that you're patching client-side vulnerabilities, because with some of those input sanitization type vulnerabilities, the issue you might run into is that vulnerabilities that your developers might have determined as being out of scope because only internal like maybe only the cache is able to interact with this certain part of the application. Well, if we're able to manipulate the cache's behavior in some way by utilizing maybe some gadget that's running on the site, then that vulnerability might be exploitable. So try to patch any of those client-side vulnerabilities, even if you believe that the attack surface doesn't merit any real attackers, because you can never be too careful and you can never be too safe. But that's really all we've got for today. I'll catch you in the next video.